All right, don't worry. Once you actually watch this video, you'll be able to see. Pardon me? Yes, here. I think there's an extra. There you go. So as you can see already with this unit is going to be completely different than our last unit. We are no longer dealing with money. We are more dealing with some more abstract thinking. So to start this all off, as much as I don't want to, there's a bunch of vocab that you need to use. Okay?
You need to memorize it?
Well, you need to know how to use it. So I'm going to see if I can figure out how to type this so I don't have to write it all out.
Maybe ask on the test. You still need to understand the actual definition.
Yeah. Yeah. So I am not going to say, what is the definition of a set? However, I will say, what is the number of elements in the set this? So you will need to know what is the terminology to use from that. So I'm going to write out definitions, because I can't figure out how to type on here, but it's whatever. So I'm going to write them out, and then I'm going to give you an example and explain it. So you have the blank set of notes. You should write this down, because you will need to know this. So a set is a collection of... So I apologize, this is going to be the most boring part of the notes. Does anyone know what distinguishable means? Yusuf, do you know? Oh, you weren't paying attention? Yassine, do you know? No, you don't? No. Mohammed, do you know? What do you know? No, about what I asked. Oh. So if one person's talking, it affects the entire class. Did you guys hear what I asked? Oh, someone was paying attention. What does distinguishable mean?
You could tell the difference between them.
Yeah, so between everyone in this room, everyone in here is distinguishable. I can distinguish between who Muhammad is and who Yassine is. Okay? There's something that is unique about them, and for our sake, we're going to say that there's no repeats. You'll hear me say this a lot, which is somewhat ironic that I'm repeating it. But distinguishable objects means don't repeat. So for example, I can give you a set of whole numbers. And if you don't know what whole numbers are, so I could say, here's a set called W. And in the set W, I'm going to put all the whole numbers. 0, 1, 2, 3, so on and so forth. Now there's some definitions of whole numbers where 0 is not included, I think, if I remember correctly, but you get the point. Here's a set of numbers, 0, 1, 2, 3, 4, 5, 6, all the way up to infinity. It excludes some numbers. Can you think of a number that's not a whole number? Decimal, so 1.5, not a whole number. So distinguishable objects, I can tell the difference between these, and it's a collection. There's a specific set of things with this. Questions on that? Okay. The completed set of this notes is also up on Google Classroom if you would rather just listen and watch and write it out later. But I'm pretty sure very few of you will actually go and copy them out afterwards. But if that's your thing, go for it. So an element is an object in a set. An object within a set. So if I asked you, what is an element in our set W? What could you tell me?
Number.
Yeah. So what would be an example? 1. 1's a whole number. That's an element. What else? 2. 2's an element. 3's an element. 0's an element. So any one of these, 0's an element, 1's an element, 2, 3, 4, 5. If you just look at one of them, that is an element. So for example, 3 is an element of W. Now there's a specific way that we write this out with a formula, and I want you to get familiar with this because you will see this on the test and you will need to know what it means. So to write this out, to say 3 is an element of W, so for this here we'd write 3, and then we write this C with a line, so a weird E. This means element. To help you remember, it looks like an E. So it's a curved E of W. So this, what I wrote here, is the exact same as this. 3 is an element of W. So the E means an element, and W is the set. So another example is if I talked about the students in this class. So a set would be all my students in the class today. Hamza, are you with me? So you guys are a set of individuals in my class. What would be an element in the students of this class? So 5 would be the number of people. But if I want an element, you name one item in that set.
The element would be students.
Well, Muhammad's an element of the set of this class.
Boy.
Yassine's an element. Yusuf's an element. Hamza's an element. Lena's an element. Each one of you creates the set of students in my class. But I am not an element of the students in the class because I'm not a student. So the element just says what individual parts make up the set.
So the set would be students and the element would be the number of students?
Not the number, the individual students in that set. Can you see the difference?
5.
So for example, this one. When I said what's an element of whole numbers, did you tell me the number of whole numbers?
No.
No. You just told me one thing that's in that set. Same thing, because sets can be made up of more than just numbers. It can be people, it can be jobs, it can be classes, it can be hobbies. There's many different things I can make a set out of. It doesn't just need to be numbers. And elements is just one of those specifics. So we can make a set of sports. We could talk about handball, we could talk about volleyball, we could talk about football, we could talk about American football. We can put all of these things into a set and say an element is just one of those items. Is this starting to make sense?
Right. Can we do the same thing with a particular sport? Like football, for example, can we make football the set and the elements the teams?
Mm-hmm. Yeah. So you can have sets within sets, which we'll get to. You're on the right track. So the nice thing about this is it's like a way to organize something. So we could talk about making a set of, I don't know, TV shows. Okay? So we could say there's a bunch of elements in the set of TV shows, but we can organize them into categories. So you go onto Netflix, you pick which you've got your sci-fi, you've got your fantasy, you've got your romance, you've got your comedies, and all your shows are sorted into those. Some overlap. But that's your elements. The TV shows or your movies are the elements, and the set is all the shows that are up on Netflix. So that's kind of what that means. So the universal set is kind of like, you think the universe, it's like this grand overview. So the universal set is everything that we want to talk about. So if we talked about students in this class, the universal set would be either all the students at the school, could be all the students in general, Could be all the kids between this range and this range. So the universal set is kind of just like this broad, big category. So I'll define this as a set of all elements under consideration, so that we are talking about for a particular context. So set of all elements for a particular context. And this will make more sense once we actually do a few examples and you can see the specific context. But right now it's just kind of the general overview. So if we're talking about our whole numbers, if that's a set, if we want to say what's a universal set of numbers, everything's fair game. So we could talk about whole numbers, we can talk about decimals, we could talk about fractions, which are technically decimals. We could talk about non-repeating decimals, so numbers that cannot be put into fractions. Anything with a number in it would be a universal set. Once we get into specific examples down below, you'll see what the universal set means. Subset. Any guesses on a subset? If you think about subcategory or a something like that. Any guesses what this would mean?
Maybe it has to do with negative numbers.
Maybe it has what, sorry?
It has to do with negative numbers.
Negative numbers? It could talk about negative numbers, but think about a set. So what is a set?
Collection of things.
A collection of something, right? So if I have a collection of somethings and I have a subset, it's like I take this collection of something and then I have a smaller collection of something inside of that.
Isn't that kind of what universal set is?
Universal is the whole thing. So if I've got a set like this, think about universal is bigger. Universe, it's huge. So it's the bigger part. Here's my set, a subset, inside. So something that goes inside or something that goes smaller than that. So the definition is a set of elements that are a part of another set. And I'll show you this with an example and it'll make more sense. So a set whose elements belong to another set. So for example, let's take our whole numbers. And let's make a subset out of this. So let's take all of our even numbers. So we'll take the even numbers. Did I say even, odd? Doesn't matter. I think I picked odd here. Let's do odd. So 1, 3, 5, so on. This is just saying keeps going on. This is a subset of whole numbers. Right? Is 1 a whole number? Yeah. 3, 5, 7, 9, 11, 13, so on. All of these are whole numbers. So this is a set where all the elements belong to a different set. Let's talk about the set of students in my class right now. So we've got a set of students in my class. What would be a subset amongst you guys?
One of those?
So it could be one, yeah. But what would be, say, a category within students in this class that I could...
Boys and girls?
Boys and girls. So Lena, being the girl in the class right now, is a subset of students. The 4 guys in this class, you are a subset of students in this class. So I could even distinguish it even further than that.
Give an example of a universal set?
Yeah, so if we're talking about, say, students in this class, we could say a universal set would be all the students in our school. So that would be a universal set of students. Or, depending on the context, we could just talk about grade 12s. So all the grade 12s would be a universal set. again, it depends on the particular context. If we're talking about grade 12 courses and which student goes in which course, then the universal would just be the grade 12 students, because I don't care about the grade 11s or grade 10s when I'm talking about just what are the grade 12s picking. So that's why I said it depends on the question, because the universal set changes. So if we've got a subset, we have the complement of a subset. So a complement is not just saying something nice about someone else. A complement is everything that's not in that subset. So how did I write this out? So a set of elements not belonging to a particular subset. I know, let me write this out, and then I will show you what this means. Elements. I forgot to write with this one up here how we write if something is a subset. So along this example with E here, so if I want to say that E is a subset of W, you know, I watched a very interesting documentary over the weekend. It's called The Social Dilemma. Have you heard of it? It's up on Netflix. It's very interesting. It's all about social media and everything involved with it, which is funny that I'm talking about it while I'm making a YouTube video. But it's an interesting watch. If you want to take an hour and a half and think about social media, it's very, it's very eye-opening. At least watch the trailer. Have you watched it?
No, what's the name?
It's called The Social Dilemma.
Social what?
Dilemma. So this is how I write something as a subset of something else. It's like the element symbol except without the line in the middle. So this little C means a subset of. Again, I'm going to show you more examples of this so you'll see this in action. I'll try and write all the symbols out so you can see what this looks like. And I have down here, I'm going to have a set of symbols. This is just giving you all this information at once, and then we'll try and sort it into its right place. So the complement of something just means the opposite, or everything that's not in that set. So we can talk about, if this is my subset E, the complement of that is the rest. 0, 2, 4, and so on. So we can say the elements that are not in this set are in the complement. So again, using the example in this classroom, if we use, let's do boys and girls. So if we say set A is the boys, then what would be the complement of the set of boys?
Tall and short boy?
No, not tall and short. It's all the elements in this class that are not boys. So it'd be Lena. That's the complement. So if we're saying, here's our subset of boys. Muhammad, Yassine, Yusuf, and Hamza. There is a set. The complement is everything that's not in this set, which would be Lena.
How would that be different from a subset?
It's another subset. So these two are both subsets of W. Yes, I know, I'm blowing your mind with the categories. Think,
Other type of subset? Also work if we say
have you seen Venn diagrams?
Have I seen what?
A Venn diagram?
Yeah.
Where you've got something like,
Yeah.
right? So if I put the categories of boys and girls, if I sort you guys, I'm not going to write your whole name. So if I've got Muhammad, I've got Yassine, I've got Hamza, I've got Yusuf, 2 Y's, doesn't matter, and then Lena. So if I've broken it up like this, here's the set of boys. That's a subset. Everything that's not boys is Lena, which is a complement, but it's also a subset of our universal set.
Wouldn't the boy set also be a complement for the girl subset? So it's basically the other?
Yeah. So I can talk about, just like here's our even numbers, the complement of the even numbers is the odd.
And the complement of the odd number is the
Yeah. So I can talk about both. So I could say the guys are the complement of the girls are the complement of the guys. You can go either way with that. Again, these vocab will make a lot more sense, more examples you get. So I'm just going to erase this now so I can keep writing. We're almost at the end of the definitions. These ones are more easy ones to understand. So empty set, exactly what it means. A set with nothing in it. So a set with no elements. So can you think of a set with no elements for the numbers that we just talked about? That's about odds and evens.
That's one number? 0?
Yeah, so, well, 0, I mean, that one's defined as a even number, so that one does fit into one. What about, what's a number that is odd and even? Yep.
Like 2 what?
So 2 would be even, 5 would be odd. 25 is odd. What's a number that's both odd and even?
I didn't know there were numbers.
I'll give you a hint. We're talking about empty sets.
Negative?
There's nothing.
Yeah.
There's no number that's both odd and even. So therefore, this is an empty set.
But, so basically a set with nothing in it?
Yeah. So we could talk about in this classroom, the subset of students in this class that are grade 11s. There's no grade 11s in this class, so it's an empty set.
So random?
Yeah.
But you can start at 0 with the other. Like 0, 3, 5, 0, 2, 4.
True, but 0 itself is an even number. Like it's just defined as even. It's technically in the middle of both positive and negative. I forget the definition if it's defined as positive or as negative, but it can be treated kind of as both. But that's getting into number theory, which I don't know a whole lot about. Okay, you guys are doing good bearing with me. We just got 2 more definitions here that we can address.
That's all we're doing for today?
No, then we're going to use those. Yeah, we're not done.
You have questions?
Yeah. But then we'll use these terms and it will make more sense. So disjoint. If something is disjoint, we talk about sets being disjoint. So if 2 sets are disjoint, there's no elements in common. So again, with the class, boys and girls, there's no both in this case. And we're not going to turn this into an argument about sexes and getting into those. I don't want to get into that discussion. We're just going to say disjoint at this point. So 2 or more sets with no common element. So talking about this, our examples, what we've got here is the set E and the set E prime, or the complement of E. These are disjoint. There is no element that is in E and E prime. So these are disjoint. We could talk about students that are in grade 9 and students that are in grade 12. There is no student that's in both grade 9 and grade 12. So therefore they are disjoint. Does that make sense?
Yeah.
If they're completely different, no elements in between, they're disjoint. And mutually exclusive is basically the exact same. It's just saying two events that cannot occur at the same time. So, for example, two things that you cannot do at the same time is be in Foundations of Math 12 and Calculus 12. Yes, there's the argument you could do an independent study and da-da-da-da-da, but there isn't anyone that is taking this and Calculus 12 at the same time. Cannot occur at the same time. Yeah, I know, my writing on here is not the greatest. Two events. So there are some things that I've thrown in here, some symbols that I didn't directly define, but they're defined down here. So if I'm ever talking about a set of objects or a set of items, I use what's called braces. Yes, it's a kind of a bracket. It's these curly ones that I used already. So this is a brace. And that's to denote a set. So if items are in those, it's a set. So if we write a set of braces with nothing in them, empty set. Self-explanatory. For a complement, it's just putting kind of like an apostrophe at the top. That means a complement, as you saw here with E prime. And then there is this C that I showed is contained within, which just means here subset. With notation? Yeah, good. I'll show you. That's not a bad thing. If you're confused, it means you're paying attention. Okay. That was only 28 minutes of definitions. Yeah, it would have been quicker if I could type it all out. So now that you've seen the definitions, let's use them. This is the more practical part of this. So let's define, it's saying let S be defined as the universal set of all numbers from 1 to 500. So every number 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 500 is S. This is our universal set, as it says here. So we want to write out S using the notation that we've said here. So we say S, our set, is equal to, and then we're going to list the elements in our set. There's multiple ways I've seen this written out. I'm going to show you the simplest way and the way I want you to write it. I'll show you the more complicated one and say don't do that. But for now, I'm just going to show you this. So from 1 to 500, so it just goes 1, 2, 3, so on and so forth until we reach 500. So please, you do not need to write out all the numbers. Just put 3 dots. That means continues until 500. So if you're going to put this on a test, make sure you indicate what the last number is. So I know you know when it stops. Technically, the most official definition of this is something that looks like this. You don't have to write it. I just want to show it to you. So it says it's X when X is greater than or equal to 1 and less than or equal to 500 when x is, what did I say? Natural number. X is a natural number. Your textbook is going to write this. Okay? I don't want you to write this. This is a great way to tell if students are just copying the answers from the back of the book because they give me this and they have no idea what it means. They just say, oh, the textbook tells me this is the answer, so I'm going to put that. So this is a nice little trick to see what you're doing. Also, for those who tend to study more by themselves, tend to do that. I don't want this, okay? If you give it to me on a test, so be it. I understand it. I just need the simple one. Just write out what they are.
I still don't understand how we will be using those definitions in class.
Yeah. Yeah. So we defined what a set is. We looked at the elements that are in it. We're going to look at two subsets. And then it'll start to go from here. So we want multiples of 5 and multiples of 10 within this subset. So we are going to take two subsets here. We're going to take the 5s, I'll write it as an F, and the 10s, and we're going to write out these sets. So multiples of 5 that are in this set. So what would be an element in this set? Yeah. Let's start at the bottom. So we get 5. 15 is right. So on and so forth, all the way up to 500. So these are all the elements that are in the set F. Notice it's a subset because every one of these is going to be in S. Let's do 10s. 10, 20, 30, so on and so forth until we reach 500. So from this, we can list subsets. So we can say F is a subset of S, because everything in F is in S. I can look at T is a subset of S. Everything in T, multiples of 10, is in the subset S, or is in the universal. Here, dot, 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 means it keeps going forever. And don't write the second one. That's just to show you how complicated you can write out notations, but I don't want you to do that. What is another subset regarding F and T? Is T a subset of F, or is F a subset of T? What do you think? So is F a subset of T, or is T a subset of F? Meaning, which one of these has all elements from the other one?
T is subset of that.
Yeah, because notice T has every element in T belongs to F, right? Because everything in this set is also divisible by 5. But I can't do the reverse. Is everything here divisible by 10?
No.
No. So therefore, this is a subset of this. What's that?
That's what I thought.
Exactly. Yep. So we would write T is a subset of F. Means T is contained within F.
So the C is a subset?
Yeah, C just means subset. So this is saying F subset of S. T is a subset of S.
What does S mean? Is S?
That's our universal set in this case.
And the one will be
Where?
has a something.
Oh, the prime, you mean up here? This is just saying it's a complement. This is something completely different. We're not using any complements in this case. We'll get there eventually. It's your choice if you want to sleep in my class. Just means you need to learn it at another point in time. So we want to write this now as a Venn diagram. You've seen Venn diagrams. So what I'm going to tell you about Venn diagrams, my universal set, always a box. So this is S. Universal, I put it as a box. Then we need to look at F and T. So there's multiple ways this could look. These could be two mutually exclusive. They could be two circles beside each other. They could be not mutually exclusive, where there's an overlap in the middle, or one is completely inside the other. So in this case, it's going to look like this. I doubt you've seen many Venn diagrams that look like this. So what does this tell us? Well, this is saying anything that's divisible by 5 goes within this circle, and what's divisible by 10 is inside this one. Because 10 in here is both divisible by 10 and divisible by 5. So it's inside both of those circles. So 20 would go in here. Out here we'd have 5, 15, 25. And what would go outside of these two circles? But still in the box. Yeah, what would go out here? Like outside of the F and the T.
What number?
Yeah, what numbers would go there? Yeah, so 1, 2, 3, 4. Any number that's in our universal set that is not in F or T. So this would be 1, 2, 3, 4. 5's in here, so I don't include 5. 6, 7, 8, 9, skip 10, 11, 12, 13, so on and so forth. So any number that's out here is just not divisible by 5 or 10. And that's a Venn diagram. So sometimes questions will just ask you to draw this.
Why can't we have numbers that are divisible by 5 and 10 on the outside? If we can have numbers that are divisible by 10 here, divisible by also 5, and side with 5. Why can't we have
Yeah, so this has to do with subsets. So,
It's only a subset thing?
so if something is a subset, it goes inside of the other set. So T is a subset of F, so it goes inside, and it's a subset of S.
Is it 5 subset of all the other numbers?
So 5 is a subset within the S, so it's in a circle inside of the box.
So why can't we do numbers that are divisible by 5?
Out here,
Yeah.
because out here is not divisible by 5. Only inside this circle are things that are divisible by 5.
Or insert the other circle?
This one's inside. So 10 is still inside our things that are divisible by 5. Same with 20. 20 is still in this circle of things that are divisible by 5. They're just categorized inside of that. You can think of Netflix doesn't do this entirely. I've had Netflix for maybe 2 months total in my lifetime. Is there a way to go into categories with Netflix? Like, can you go on the side and is there a categories box? Anyone who does? Okay, so then let's talk about what's something else we can talk about with this. Okay, let's talk about Google Classroom, because hopefully you all use Google Classroom. So in Google Classroom, when you go onto the site, you've got the Google Classroom for you is the universal set. Right? That's everything where you have for Google Classroom. Subsets in Google Classroom would be Foundations of Math 12, whatever your other classes are your subcategories in your Google Classroom. You following me? Make sense?
With the assignment.
Yeah, so you're going into each subcategory as you go.
With the assignments inside of like foundations be like a subset?
Would be a subset of your class, which is a subset of, yeah. So anytime you're organizing something smaller and smaller, you get into a smaller subset inside of a subset. It's like Inception, except with sets.
What the Google Classroom is a universal set?
So in this case, we would call Google Classroom the universal set. But if we talked about websites used, the universal set would be all the websites that are on the internet. And then Google Classroom is a subset of all the websites, and then the classes, and then the...
It changes based on the context that you were giving?
Yeah. Yeah. So like here, we were told we're using the universal set of just 1 to 500. That's not all the numbers, but in this case, the context says 1 to 500 is our set. One more example. This one should make sense. Okay, so if you roll 2 4-sided dice, which there is such a thing as a 4-sided dice, these are all the outcomes. So if I rolled a 1 on one set of dice and 1 on the other, it would add up to 2. Then if I did a 1 and a 2, it adds up 3, 4 and a 4 adds up to 8. So this is just a nice table to represent the sums of what you roll on each dice. So we want to display the outcomes of this in a Venn diagram. We want our categories to be rolls that produce numbers that are less than 5 and numbers that are greater than 5. So basically we're just going to organize these into subcategories. So let's use blue to do all the rolls that produce less than 5. So this one's not going to be too hard to do. Just look for all the numbers less than 5. So 1 and 1, 1 and 2, 1 and 3. 2 and 1, 2, 2, and 3, 1. So these 6 numbers are my subset of rolls that produce less than 5. Let's do the same for greater than 5. So again, look at the numbers greater than 5. Subset, subset, subset. So I've got 2 subsets. And let's draw this in a Venn diagram. So what you need to think about this is, are these 2 events mutually exclusive? Mutually exclusive? Think of exclusivity. So if you got like an exclusive club, only certain members are allowed in that club. So are these 2 mutually exclusive, meaning they're disjoint, meaning they don't have any elements that are in the same, right? There's no outcome that is both less than 5 and greater than 5.
I have a question. Would the 5 be an empty set? Because they're neither...
So they're not empty because I've got 4 cases where I've got a 5.
But they wouldn't be either of both.
Correct. So we'll show that in the Venn diagram. Just like in here, these are the numbers that are not included in any of the subsets.
So it's going to be universal set? Would it be?
Well, let's draw this. If I wanted to look at an empty set in this case, it's what's the sum, or which rolls give you a sum of 10? That would be empty. There's no case where I can get 10. So if we look at this, we said these are mutually exclusive, which means in a Venn diagram, it's 2 separate circles. So I'm just going to call this A and call this B. So we're exclusive. And I want to put each of these outcomes in these sets. So I'm going to put everything that's A into my set here. So we said rolling a 1, 1 goes here. We said rolling a 1, 2. We said a 1, 3. 2, 1. 2, 2, and 3, 1. So here are all the rolls that are going to get us into category A. a sum that's less than 5. And we do the same for B. So these would be 2, 4, 3, 3, 3, 4, 4, 2, 4, 3, and 4, 4. These are my different sets. But as we already talked about, there's still 4 outcomes that are in neither of these sets. But are they still a part of our universal set?
Yes.
Yeah, right? It's still an impossible outcome. So where do they go in this diagram?
Outside of both diagrams?
Outside of A and B, but still in the universal set. So this would be, let's put them in the center here. So 1, 4, 2, 3, 3, 2, and 4, 1. Guys, I've got 2 more parts to this, and then I'm going to be done. And then you can talk. Sure, if you want to sleep and do this at home, that's your choice. Yeah, once I'm done. But then you have practice problems from the textbook. So, what's what? U, universal set. So now we want to record the number of elements in each set. So there's a specific way we write this out. I'm just going to familiarize with this. So if we want to know the number of elements in A, you'd write it like this. N, number, set A in brackets, equals, what are the number of elements in A? Yeah. How many elements are in the set A? 6. Number. So this is just saying what's the number of elements in now set B? 6 as well. Pardon me? The N means number. So this is saying what's the number in A? Number of elements in A, number of elements in B. And if we looked at what's the number of elements in U, the universal set, what would that be? So the universal set means all the elements in this box. So it's 6 here, 6 here, and 4 here. So in total, no, there's a different way to write only in this area. But everything that's in B is still in the universal set because it's a subset. So it's still included in that general set. So there's the number of elements in each set. Determine the formula for the number of ways that a sum less than or greater than 15 can occur. Verify your formula. I can show you what this is, but I'm not going to be super picky about it. Let's just leave this. Don't worry about determining this formula for it. It's pretty, I mean, I can write it out. It's just NA, so the number in A plus the number in B is equal to the total number, which is the universal, minus 4, because there's 4 outside. And then you can verify, you just plug the numbers in, it works. But that's essentially what it is. Just so you can see it written.
So then we just figure it out from outside, we have to show whatever.
This is just making an equation. So if I change the number in the universal set, or if I change the number in A and B, it changes. Yeah, minus 4. Yeah. Because if you try it, 6 plus 6 gives you 12. 16 minus 4 also gives you 12. So it works. But for this, I don't need necessarily a formula for you to write it out. If you can just figure it out using logic, I'm fine with that. Just show your work and you're fine. I don't necessarily need the equation for it. Okay, that's the first set of notes. So as you can see, drastically different than the last unit.